What's the point of intersection here? X equals to 3 and y equals to root 3. Good. And what's the area like I want? So find the area of the region bound by the two curves and the x-axis. So you can do half of the 0 to, yeah, you can. But you need to realize that's a symmetrical graph first. If it's not a symmetrical graph, you can't do this way. Um, there's like, first of all, we should realize this is not the area between the graph. It's area under the graph. Okay, so this is not really, this belongs to this exercise. It's not area between two graphs. It's the area bound between the graph and the x-axis, not between two different graphs. And if I cut this in the middle, if I shade into red this half, can you see the left half and the right half are exactly the same? They have the same like rate of change, like it's root x and minus root x, root minus x. They have the same gradient, so it's symmetrical graph. If you can realize it, I can go 2 times the integral of 0 to 3 of root x dx. But if you can't see this, we can go 0 to 3 of root x dx plus 3 to 6 of root 6 minus x of dx. Well, see, 0 to 3 of the left hand half and 3 to 6 to the right hand side half. But if you can see that symmetrical area, we can just times this by 2 times 0 to 3, that half by 2. How you can simplify 3 to the power of 3 over 2? Was 3 root 3. So it's root 3 times 3 times. So it's a 3 root 3. And that's just a 4 root 3 here. There's a root 3 times root 3 times root 3. And that's a 3 root 3 times with the 4 on 3. We get 4 root 3 here. Alternatively, we can just use the bottom one. If you can't see the area is half and half, like symmetrical. If you can't see it's symmetrical area, we can just go 0 to 3 and then 3 to 6. Boys, hello. Okay, example 8. Um, find the points of intersection of the function y equals to 2x and y equals to negative x squared plus 8. So y equals to 2x. I'll just sketch that on the graph first. And be aware of the domain. The domain is greater or equals to 0. So that one is y equals to 2x. And we have another one is y equals to minus x squared plus 8. Okay, minus x squared plus 8. Which is this half of the graph. We have 0, 8. And that's 2 root 2 comma 0. So also find the intersection between them. And we can work out the point of intersection by solving the quadratic, and that's 2 comma 4. Um, A is find the intersection. B is sketch the region bound by the two functions and the y-axis. And we want to work out this area. We can see this area is the area between the curve. Okay, this is not bound by the x-axis and the graph. It's bound between the two graphs. And we can see the red one is on top. So it's minus x squared plus 8 minus the 2x in between 0 to 2 and to the intersection. And we can work out this pretty easy. It's 28 over 3. All right. I think I still have some time. Um, Oh, yeah, I'll stop here and I'll start of next period. I'll go through a little bit for exercise D. I'll just do a little bit for exercise D. You can work on a couple of examples for these two exercise first. And start of next period, I'll just go a little bit of introduction for part exercise D. Um, this one's find the volume of revolution. So if you have, like, I'll just show you examples first. If you have this graph and the line is y equals to half x. So I have this line here. And I also shade the region in between 0 to 4. I'll shade this yellow area here, and that's a triangle. And this triangle will be rotated about the x-axis. And think about the triangle. Rotate about the x-axis, we will have like the circle point here. Okay? And what we want to work out was what we want to find is the volume. Rotate by this triangle, like this circle point here. Okay, that's all I want to work out. So this is the area rotate about the x-axis. And then another one we have y equals to x squared. And we have shaded the area in between y equals to 0 and y equals to 20. So I've shaded this yellow area here. Okay, so two horizontal lines. This is the area bound by the y-axis. It's not the area bound by the x-axis. It's the area bound by the y-axis. And this area will be rotate about the y-axis. And you can imagine that will be kind of like a ball. Okay, so what I want to work out is the volume of this ball here. So this is the two different way. Okay, so one's rotate about the x-axis and the other one's rotate about the y-axis. What we want to work out is the volume of those shapes, okay, being rotated. So firstly, I think I want to correct one of your formulas here. Sorry, I typed it wrong. So the last one here should be dy, not dx. I changed on mine, it's working already. So that change that. Your one should be, I think it's dx. It's the old version. I haven't added that. So it should be dy there. All right. So how to work out that? There's like two formulas we can follow. There are two formulas we can follow. But the general thinking is, well, think about that. When we rotate something, like the base is always kind of like a circle. Think about that. If there's a point and rotate about the x-axis or y-axis, you always create something like a circle. That's why in the formula we always have a pi here. Normally volume is like base times height or a third base times height or like 3/4 like 4/3 base times height. Like the base is like a circle, so you always have the pi here. That's why we have a pi. It's a really rough explanation, but that explains why we should have a pi there. Okay, something like a circle is related to circle, and then we have a height. And how we remember this formula? Okay, so I just tell you some is like, I think it's a way to remember it. So what we need to do here is think about the first one. I just use the first one as an example. So we always should start, the volume always should start with a pi. As I explained, the circle involved, we have pi there. But pi is a constant. I don't need to really integral that. And now what we think next is which axis we rotated about. Like, so we rotate about the x-axis, we rotate about the y-axis. So which axis we rotate about, we put d what at the back. So if it's rotate about the x-axis, we put dx. If we rotate about y-axis, we put dy. So same as this one. So volume should equals to pi integral of dy in this question, because this area has to rotate about the y-axis. And then the next thing we need to think about is how this area has been formed about the x-axis. So if we look at the graph this way, yeah, so rotate about the x-axis, we should look at this way. If it's rotate about the y-axis, we should look at this way. Okay, so make y in front of you and see how the area has been formed. So this one is the area formed between the curve and the x-axis, between 0 to 4. Okay, x value between 0 to 4. So what we need to think about here is dx. Those two values must be x values. Okay, dx, those two values must be x values. So in this case, x is 4 to 0 here. Now left is 0 and right hand side is 4. So in between which value to which value you can form this area. And now how we form this area is area bound between the x-axis and the line. Okay, between the x-axis and the line. So if it's between the x-axis and the line, and remember in this place we should have things in terms of x. Because I want to dx, so in terms of x. But in this box we should have in terms of y. Because I want to dy. Okay, so after you, okay, the first thing we need to rotate about which axis, when we put dx or dy there. Then that decide what you can have in between. If it's dx, we have in terms of x. If you have dy, we have in terms of y. So now equation is y equals to a half x. Okay, this is good to use because I want to substitute x in the equation about x in. So we have a half x here, but we need to square it. Because we're talking about volumes, we need to square. Like that's not really the real explanation. But just remember there's a square of the function. Okay, the square of the function. So square which function? I want to square the function which relate to x. Okay, got like expressions in terms of x. We will square that one. But for the next one, we have y equals to x squared. We have y equals x squared. I want to square a function in terms of y, but that's not the case. So we need to rearrange the equation to make x to be the subject. Okay, also it's on the positive side. We only think about positive side. So x equals to root y. So now x is root y. Root y is the function because I need a function in terms of y. So I have root y here. Then I'll square that function. Okay, I'll square that function. So the d what decides all of these values. And this one is a y value in between, made in between 0 to 20. So we put 0 to 20 there. Okay, because it's a dy here, then we need to look at the y value, how to make this area. So this area is made by the graph and the y-axis in between y equals to 0 to y equals to 20. So we have 0 to 20, that must be y value. So this thing is after you fix that, you know what should be here and you know what should be the value. So if it's dy, we should look at the value on the y-axis. If it's dx, I need to look at the value on the x-axis. And we can just antidiff that and work out the value. So in the exam, in the VC exam, most of the case they will ask you to give an expression and then ask you to use test to evaluate that. So the evaluation is not a big thing in this question, but it's how you set up the graph. So if you can go to page 10, let's just do like a couple of examples. So sketch the area bound by the A is sketch graph root x, bound by the y-axis and the line y equals to 3. Okay, so we have y equals to root x. And we have line y equals to 3. And the y-axis. Okay, the region I'm talking about, I'll talk about is this area here. Okay, this is the area shade. The shading area is bound by the y-axis, y equals to 3, and the line y equals to root x. And this area is made by the graph between the y-axis and the graph, in between 0 to 3. Next is the blue line, the area under the curve between the y-axis and the actual graph, in between 0 to 3. Okay, in between 0 to 3. Okay, the question says the region is rotated about the y-axis to form a solar revolution. You can think about the shape. The shape is roughly like that. Like you don't really need to think about. You don't need to worry about the shape. But just for interest, it should be something like that. So what we need to think about is this is rotate about the y-axis. We are applying the front integral of dy first. Okay, integral about dy first. If it's dy, then we look at the y value, how this area has been formed. So we look at the y value. Is the y value in between 0 to 3? So that line here is 3. So we have 3 to 0 here. Okay, so 3 to 0 here. Then this equation should be an equation in terms of y. Okay, in terms of y. So I have y equals to root x. That's the equation in terms of x, which is not good. I will have x equals to y squared. So what we have, this is the equation in terms of y. But remember to square that equation as well. So it's basically y to the power 4. Okay, so it's dy. What we need to write is dy first. And then the y value is from 0 to 3. And then the equation needs to be in terms of y. So it's x equals to y squared. And then y to the power 4. I'm not going to evaluate that. Okay, I just want to give expressions to set up how to work out the volume. And if you look at the next one, sketch the area bound by the curve, like this curve. And x-axis and the line x equals to 3. This is the region I'm looking for. Okay, so first of all, you should realize what is the region we talk about. So the region bound by the curve y equals to root x, the line y x equals to 3, and the x-axis. Okay, so this is the area formed by the x-axis, which is great. So find the volume, like when we rotate this one. So volume should equal to pi times the integral. And your entity, like integral, rotate about the x-axis. So we have dx at the back. And the area is formed between the graph and the x-axis from 0, 3 to 0. Okay, so it's 0, 3. Okay, on the x-axis, this point is 0, this point is 3. I need an equation in terms of x. So this equation is in terms of x, which is good. And I'll square that equation. So it's root x squared. Alright. I'm not going to evaluate that. So that's just antidiff of x, so which is easy. If you go to part C, just want to set up the equation with you. So sketch the area bound by the curve y. Still the same question. Bound by the curve y equals to root x. The y-axis and the line y equals to 3. So it's the same graph as part A. That is y equals to 3. And this point is 3, that point is 0. So the area bound by the y-axis, the curve and the line is this one. Okay, the problem now is the region is rotated about the x-axis. Again, what's the problem here? If this region is rotated about the x-axis, what's the problem? What's the difference between A? Andrew? It's the outside bit of the ball, correct? So it's like when we get the cylinder and then we get rid of the ball, like this ball here. Like we get rid of the ball from the previous part. Okay, how we can do this type of question? So we rotate about the x-axis, but the area is not formed between the x-axis. That's the problem. If you form the area between the x-axis and rotate about the x-axis, it's easy. But this one is rotated about the x-axis, but formed by the y-axis. That's different. So what we need to think about here is a volume. So we get pi. We have integral. We rotate about x, so it's a dx. Yeah, that's all the same as before. We look from the side. Okay, so we look at the paper like this. Okay, so x-axis is in front of me, horizontal x-axis. Can you describe to me how you can form this area? Is that area between the curve or between the line and the axis and y-axis? Like, how you can form? Can we describe that area between the two lines? Yeah, so y equals to 3 and y equals to root x. So it's the area bound between the line y equals to 3 and between the line y equals to root x. From, well, what is this point? That's 9, right? So is the area bound between the curve from 0 to 9, in between which two graphs? Y equals to 3 and y equals to root x. Okay, it's in between those two graphs. So this is like a little bit harder compared to the previous session. Is this area is formed between two things, not formed between one thing. So what we need to do is use the top function squared minus the bottom function squared. Remember, you still need to have things in terms of x, and this is in terms of x, which is good. So what we have, the top function is y equals to 3, which is 3 squared minus root x squared. So it's the top function minus the bottom function as square both function. So square of the top function minus the square of the bottom function. Okay, so that's how you work out the area if it's not bound by the x-axis. Okay, so it's bound between the two lines. Okay, bound between the two lines. And we should put is 9 to 0 here, because the area is formed between 9 to 0. Okay, so it's in between the two vertical lines x equals to 0 and x equals to 9. All right, I'll do last one. Last one is sketch the area bounded by the curve y equals to root x. The line x equals to 3 and bound between the x-axis. So I'm talking about this area here. Yeah, I'm talking about this area here. But the region is rotated about the y-axis. Okay, so it's this region, there's a point and rotated about the y-axis. So what's that point? Like that y value? What's that? Root 3. Good. Okay. So we have volume should equal to pi times integral of rotate about y. So it must be dy here. Okay, so because it's rotate about y, so we need to look at the graph this way. So put y as horizontal, so put y in front of you, that's horizontal axis, and describe to me how you form that area. So it's in between which one and which one? Yeah? So minus the bottom one square, right? So the top one is the red one. So it's bound between this graph and this graph. Okay, bound between here and here. In between y equals to 0 to y equals to root 3. So that's how you look at the graph. You can rotate your book to see it. So is this graph is y equals to root x. But remember, I need in terms of y. So x equals to y squared. So the top function will be the red one. So that's 3 squared minus what? Minus y squared and then squared it as well. Okay, squared again. And we have from y equals to 0 to y equals to root 3. So the value we put on should be 0 to root 3. And that's how you look the graph and how you work it out. All right, so I'll stop here. Tomorrow we'll finish up this exercise. But that's the basic idea of how you can work on the revolution volume. So you need to worry about which x-axis I'm rotating that about and which function is above which function. So how you get this area done and how you work out this shading area. So you can try some questions on the textbook, and I'll finish up the next 2 pages tomorrow. If you have time, you can sketch the graph first, and which we can work out that like quickly tomorrow.